Hi guys. Okay, this video will be going more in depth, looking at more graphs from the transformation we learned. Just for like a quick recap, and if you're still confused, go to my playlist called Transformations, and it will be over there. I'll put it at the end of the video. So, sorry. A quick recap. We have the vertical functions that shift the graph up or down. We have the vertical shifts. We have the horizontal shifts left to right. We have the reflections over the y-axis. And over the x-axis, and then this is over the y-axis. Then we have the stretches. If a is greater than 1, it stretches. If 0 is less than a, is greater than a, no, if a is greater than 0 but less than 1, it compresses. So for like example 2x square will stretch and 0.5x square will compress. And if b is greater than 1, it compresses. But if b is greater than 0 but less than 1, it decompresses. So for vertical, it goes up, goes down, and then for horizontal, goes to the left, and this goes to the right. So I'll just do a big giant one together and say where everything goes. Okay. Negative 2x plus 1 square minus 3. So it goes left by 1. Left by 1. Down by 3. It has a vertical stretch of 2. And it reflects over the x-axis. But I'll put it in Desmos for you to see. So Desmos is a graphing app. You can use it to check your graphing. Okay, so it went down. Okay, it went down by 3. Right over here, it went down by 3. It shifted to the left by 1. For emphasis, I'll show you how an actual graph looks like. Actual quadratic graph looks like. So we can see it's moved to the side, left. It moved left, but before it moved left first. Then it reflected over the x-axis, which is why it's looking like it moved right, but it actually moved left. It moved down by 3. It moved down by 3 first, then moved 1, then moved left 1, then reflected, and then it's stretched. As you can see, don't know if you can see that, but you can see it's a lot thinner than this. It's a lot thinner. Okay, now that we have some, I can't find the word. Okay, now that we have some refreshes, let's look at some graphs. Okay, so x minus 3 square plus 2. If you remember, we did what we called mapping, where we had x comma y equals to 1 over b x plus h comma a y plus k. And this is h, this is k. This is like a simple graph. This is always the opposite. This remains the same. So this will be plus 3. So it will be x plus 3 comma y plus 2. So it's moving down by 3, and it's moving to the right by 3 and moving up by 2. So an example would be x minus 3 square. We know it's a quadratic equation because of the square, plus 2. For comparison with an actual quadratic equation, we can see this is the original, blue is the original, and green is the transformed graph. We can see it moved up. You can see it moved up by 2 and right by 3. And it's basically the same thing, except it moved up and right by 3. Another one is we're going to look at an absolute value graph. This is a normal absolute value graph, exactly like a quadratic, except it's in a V-shaped graph. And negative 2x. We know immediately that it is going to reflect because of the negative. And when the negative is over here at this side and not in the bar, we know it's the y. It's relating to the y. And we know that the y side is reflecting over the x-axis. So if we write it like this, it will be x comma negative 2y. So it's going to stretch by a factor of 2. So I'll show you an example over here. Negative 2x. So as you can see, it reflected over the x-axis, and it's, I don't know if you can see this very well, but it's slimmed down. It's slimmed down. It's slimmed down. Okay, why is it showing 100? Sorry. Okay. It's slimmed down. Let's look at another one. We're going to look at square root function. I believe is what it's called. Yeah, a square root of a function where you square root. I'm going to show you an example of a square root function. It has a curve, a slightly curved path. It does not go into the negative side because you cannot square root a negative number. And it goes, so this basically the square root of 4 is 2, the square root of 9 is 3, and the square root of 16 is 4, and so on and so forth. So if we go create space, a square root of 2x plus 4, the 2 is inside the bracket, so we have to break it out. So it will be 2x plus 2, and it will have while it will move left by 2, because to be x minus 2, 2x minus 2, comma 1 over 2x minus 2, comma y, which means it will be fat. It will be a fat graph. So let's do that. Square root of 2x plus 4. As you can see, it's moved left by 2, and it became doubled in size, as we can see by this. So now let's combine everything together because we've been looking at them separately. We first looked at vertical and horizontal shifts, then we looked at reflection and vertical stretches. Then right now what we're looking at is horizontal compression and shift. And let's look at it combined. This is a quadratic graph. The best way to do this is map it out. Let's start with the b. So there's no b, so x minus 1 comma negative 0.5 minus 3. So what can we say? What can we tell immediately is going to happen to this graph? We can tell it's going to move left by 1, down by 3, and it's going to become bigger, fatter, if you will. So let's put it in and combine them side by side. Zero 0.5 x squared, no, not x squared, why did I do x squared? X plus 1 squared minus 3. Okay. As we can see, it reflected. Okay, it reflected, but before it reflected, it moved down by 3. Then it moved 1 to the left. It became bigger. You can see that here at originally it was at 2, 1, negative 1. Became fatter. Yeah, that's what I'm trying to show. Let's see, put the point. I'm trying to get just anyway. Let's see it actually come to life. So let's start with x plus 1. Okay, we see move to the left one. Then x squared minus 3. You see it drop down by 3. Then 0.5 x squared. We see it double in size, and this actually creates a better picture of what happened. Oh, negative x squared. Yep, this creates a better picture of what happened. It's a little bit jumbled right now, but let's do it this one by one. Looking at the red graph only, we see it moved 1 space to the left, which makes sense with our prediction, x minus 1 moving left. And looking at the blue graph, this one right here, we see it dropped down by 3. Then looking at the green graph right here, we can see it doubled twice its size, and then it reflected on the x-axis, basically turned around. Let's try one more example using a radical graph. Not a radical graph. Let's try one more example. Just with done absolute value. We've done quadratic. We have not done reciprocal. Okay, let's try one more example with a reciprocal graph. Reciprocal graph will have a line in the middle because of the zero. You can't divide numbers by 0, so it will be undefined. This is what a normal graph would look like. You can't see the line, but if I scroll up and then zoom in and then just keep on going, you can see it is getting closer and closer and closer and closer to the line, but it's never meeting that line, but it is going closer and closer and closer and closer. That's one of the things I love most about reciprocal graph. That's linear. There's also sine, cos, and tan graphs. There's sine, cos, and tan graphs. There is polynomial graphs. There's exponential graphs. Basically, once you get to grade 12 pre-cal, almost every single thing has a graph. And for the next few weeks, we are going to cover every single graph that you learn in grade 12 pre-cal. So for those of you that are preparing for a provincial exam, I hope these questions will help. And then one of these weeks before the provincial exam date, we will look at some past questions and I'll go through solving it and how to solve it when you get to the pay front of your provincial exam. Okay, so let's try reciprocal example. 4 over x minus 2 plus, not plus, minus 1. So mapping this, you guys already saw the graph, but okay. 4 over x minus 2 minus 1. It is slightly different to map. we map it like this: a over x minus h plus k. So this will be x plus 2, comma 4y minus 1. Then we need to find the non-permissible value, which is x minus 2, which would be, oh sorry, I don't know when I moved there, which would be x cannot be equals to 2, and the non-permissible value is what x cannot be. So means at x equals to 2 is where the line just go and they'll curve like this right here, just never hitting the 2 graph. And then we'll find the horizontal asymptote, which means take this equation 4y minus 1 and input 0 in, and the answer is -1, which means at -1, this line is -1, the graph will just go, never quite hitting it. So let's see that. Okay. Okay, we have 2 different graphs. Oh, another thing is you also have to find the graph when it's being 1 1 and -1 -1, which in this case would be 3 3 1 -5. You just input it in here, the x part in here. 1 plus 2 is 3. 4 times 1 is 4 minus 1 is 3, and same thing with this. And then come over here, 3 3. Oh, where are we? What graph is this? Blue. This is 3 3 right here. Can't quite get the like, but this is 3 3. And this is where you start the graph from and just draw it. Oh, just draw it, and you can see here it's going down to 2, but never quite reaching it. Same thing with this one, it's 1 -5. Sorry, it's this side is -1, not 2, and this side is 2. And yeah, try, okay, we saw how different transformation works, so try looking for equations and solving it on Desmos.